All right, in this video, I'm going to be working some examples of integrating products. There's going to be a lot of integration by parts, but there will also be some U/U and just some other integrals that start off with a product. Okay, and this is BC Homework 9.1. So we're going to start off with a set of 13 integrals that we're just going to compute by hand. And it looks like, some of them are indefinite integrals, some of them are definite integrals, and there's one over here that's another indefinite integral that's going to require integration by parts twice if you know how to recognize that. But, let's just jump in there and start with it. X e to the negative 2x. Antiderivative. Okay. So this is 1a. Right, that's how they're numbered. Yeah, okay. So x e to the negative 2x. So I'm going to let u equal, so I think I late. Algebra comes before exponential, so I'm going to let u equal x. And then I'm going to let dv equal the rest of it, e to the negative 2x dx. Okay, then I'm going to take the derivative of u, so du dx equals 1, and then du equals 1 dx. And then I'll take the antiderivative of dv. So that gives me v equals negative 1/2 e to the negative 2x. Okay, the negative 1/2 to prepare for the chain rule. Okay. Now, we know that the integral of u dv equals u times v minus the integral of v du. Okay, so I will use that, and I will just plug in on that. So this integral here is going to be u times v, x. So negative 1/2 x e to the negative 2x minus the integral of v du is just going to be, okay, so that would become a plus 1/2, the minus negative half. Integral of v, that's e to the negative 2x, du is dx. Okay, so this will be negative 1/2 x e to the negative 2x plus, okay, well, when I take this antiderivative, I'm going to incur another negative 1/2. So to combine it with that, I would have negative 1/4 e to the negative 2x. And then I'm going to add a plus c because this is an indefinite integral. All right. And then, okay, well, that's it. Yeah. The second one is going to be 4x secant squared x. All right. So what's it? 4x secant squared x. 4x secant squared x dx. Okay, I late algebra comes before trigonometry, so I'm going to let u equal 4x and dv equal secant squared x dx. Okay. Now I'm not going to show myself doing du dx and then multiplying both sides by dx and copying this down but with an antiderivative symbol next to it. We're not going to do that each time. We're just going to take the derivative and multiply it by dx all in one go, and then we're just going to anti-differentiate because we know that's the process we go through each time. And so v is going to be an antiderivative for secant squared x with respect to x. That's tangent x. Okay. And we know that the integral of u dv is equal to u times v minus the integral of v du. Okay, so what I've got is going to be uv, 4x tangent x, minus the integral of v du. Well, it's one of the best choice ever for the second problem on the homework. Okay, because you're here and you're like, oh, what's an antiderivative for tangent? That's not part of this class, is what I'm telling you. Okay. Antiderivative for tangent, what you're going to want to do is, you don't even have a textbook if you're in my class, but you do have a telephone on you that's. You might be watching this video on that telephone. You just flip over to your internet browser, look up antiderivative for tangent, and you'll see it's log of cosine, negative log of cosine. I do have a textbook, so let's see. Yeah, negative log of absolute value cosine u plus c. Negative log of cosine. Okay, so that's going to be 4x tangent x plus 4 log absolute value cosine x plus c. Pardon me, that should not have happened. But, you know, it's there. It wasn't that bad, provided you knew that antiderivative. But I just want to emphasize this is not something you have to know in my class or in AP Calculus at all. Okay, and then that's an antiderivative. Let's do one more before my next class comes in. Let's see, 1c is going to be x log x. Okay, perfect. This is a good, very typical one. This should have been number 1. Okay, so antiderivative of x, natural log x, dx. I late. Log comes before algebra, so I'm going to let u equal log x and dv equal x dx. Okay, so I take the derivative. Derivative of log of x is 1 over x. And an antiderivative for x would be 1/2 x squared. Okay. And I'm going to copy the formula each time, because that's what you should do as well, if you don't already know it. If you know it, debatable as to whether you need to copy it that many times. But if you don't just have this down yet, you need to just copy down the formula each time, and that will help you remember. Okay, so u times v is 1/2 x squared log x minus the integral of v du. Okay, and then that's going to be, I'm going to have to do a little simplification, but that'll just be 1/2 x. And we know how to anti-differentiate that. We would add 1 to the power and divide by the new power. So it's going to be 1/4 x squared. And we'll add a plus c because it's an indefinite integral. Okay. Yeah, I've got my class coming in now. I'm going to have to pick this up in a few minutes. Okay, I'm back. Class is over. 1d. This one is t squared e to the t to the 3. dt. Okay, this one, you can't even see that. This one is the product of a composition of functions and the derivative of the inside, or at least something proportional to the derivative of the inside. And that is the u du pattern. So I'm going to say, all right, I need to let u be the inside of the composition of functions, the thing whose derivative is appearing elsewhere in the integral with multiplication. So I'm going to let u equal t to the 3rd. Okay. Du dt is 3t squared, so du is 3t squared dt. Okay. But I don't have 3t squared dt, I just have 1t squared dt. So I'm going to solve for t squared dt. And that's going to be 1/3 of du. So this and that are going to turn into a 1/3 and a du, and this will become e to the u. Okay. So this is going to become integral of e to the u times 1/3 du. Okay. An antiderivative for e to the u with respect to u is e to the u. And so that's 1/3 of e to the u plus c. Okay. And that's a u substitution one. And, you know, we're kind of getting to the point where we need to be able to do u versus u dv. Okay, that's why the title of the lesson was integrating products, not integration by parts. Okay. I've learned my lesson over a couple of years. So e, x squared minus 1 e to the x dx. Okay, I like this one because I feel like there's a message in all of these, but x squared minus 1 e to the x. Okay. All right, and what I'm going to do, I'm going to distribute this first because, you know, might be that I can do some of it with, I think the x squared e to the x is going to require integration by parts and minus e to the x. Well, that'll be fine. But I'm realizing I would let that be u. Oh, yeah, no, there's nothing to gain by distributing. If you think through what's going to happen, antiderivative of e to the x is e to the x, that's fine. X squared e to the x is going to require 2 iterations anyway, and so is x squared minus 1. And when I take, u equals x squared minus 1, du, the minus 1 will go away anyway, so I think that's going to be the thing to do. All right, so let's do u equals x squared minus 1, algebra before exponential and I late. So I'm going to let u equal x squared minus 1 and dv equal e to the x dx. Okay. And then I'm going to take the derivative and the antiderivative. Okay. And then, well, we know that the integral of u dv is equal to u times v minus the integral of v du. Okay, and I just kind of fill in on that formula. This is going to equal u times v minus the integral of v du. So that would be 2x e to the x dx. Okay. This is also going to require an integration by parts. And so I'm going to go over here and I'm going to say let u equal x and dv equal e to the x dx. So the du is a dx and v is e to the x. Okay. And then, this secondary integral, this is going to become x e to the x minus the antiderivative of e to the x dx. Well, that's just going to be a minus e to the x. Now, at the end, there's going to be a plus c. But I'm just going to kind of copy all of this down. And then add c, right? Because it's an antiderivative problem. All right. That was a good old-fashioned 2-iteration integration by parts example. What's question F? T squared e to the 2t. That's going to be another 2-iteration one. And I'm sure there's enough room, but maybe there is. Maybe there's just enough. All right, so 1F. I'm going to let u equal t to the 2 and dv equal e to the 2t dt. Now, I think I know I put this one on here because the derivative of t squared is 2t. And you might be saying, oh, wait a second, isn't this a u/du situation? But this is the composition of functions. And we can't have the derivative of something else appearing inside the composition. That's not the u/du pattern. Okay, derivative of the inside of the composition to be appearing on the outside with multiplication, not the other way around. So du is 2t dt, and v equals 1/2 e to the 2t, right? Because of that 2. Prepare for the chain rule. Okay. Okay, we know that the integral of u dv is equal to u times v minus the integral of v du. So this is becoming t squared, uv is 1/2 t squared e to the 2t minus the antiderivative of v du. Well, 1/2 and 2 is going to multiply together to make 1 t e to the 2t. This is going to require u dv also. And so we can make that happen by letting late algebra before exponential. U equals t, and dv is e to the 2t dt. I didn't write it down there, but I definitely meant to put in the dt. And I'm going to take the derivative and the antiderivative. I'm going to say, all right, well, this integral is uv minus the antiderivative of v du okay. And, all right, well, this is becoming 1/2 t e to the 2t minus a quarter, because I'm going to have to divide by 2 for that again, and I already have a half there, so it's going to be a quarter, e to the 2t. Okay, that's what we're going to be subtracting right there. I still have this. And I'm not going to forget to add my plus c because it's an antiderivative question. All right, that was our good, nice first set of indefinite integrals. Now we're going to switch over to do some definite integrals, and well, those are pretty much exactly the same. All right. Oh, sheet. So for 1g, zero to pi x sine half x dx. All right. So, just a second. All right, so I'm going to let algebra before trigonometry. I'm going to let u equal x. And dv equals sine of half x dx. Okay, take a derivative, take an antiderivative, so that would be -2 cosine half x. Let's check that and make sure, okay, the derivative of cosine would be negative sine, taking care of the negative, and then I would have to multiply by the half for the chain rule, thereby taking care of the 2, so I would have sine of half x. Yeah, okay, I'm convinced. And
students, pardon this interruption.
Pardon me. And, all right, we know that the integral of u dv equals u times v minus the integral of v du. Okay, so this is going to -2x cosine of half x minus the integral of v du. So that would be +2, right? Because minus the integral of v, it's going to be +2. Integral of cosine half x dx. Right, and then, all right, this antiderivative would be sine of half x multiplied by 2 to prepare for the chain rule. So I'm going to have four sine half x and plus. Nope, not that, because it's going from 0 to pi, pardon me. But this is an antiderivative, and you know, if you were to run into a similar issue like this, you know, make a mistake like that, what you can do is you can say, okay, I got myself an antiderivative. That's all I need, really, right? I can let this run from 0 to pi, and that's going to be, all right, -2 pi times cosine of pi over 2, that's 0, plus 4 times the sine of pi over 2, and that's 1. And that's when I plugged in pi. And then when I plug in 0, I will get 2 times 0 is 0, plus 4 times the sine of 0 is still 0, and then I think that's going to be 4. H is integral from 1 to e of log x dx. All right, so I'm going to let u equal log x and dv equal dx. And this time I'll remember to do it kind of in one go. So now I've got it all set up. I'm going to say that this is equal to u times v, so x log x, as x runs from 1 up to e, minus the integral from 1 to e of v du is going to be x times 1 over x dx, is just 1 dx. All right, so this is going to be e times the log of e minus 1 times the log of 1 minus, well, the integral from 1 to e of 1 is just going to be e minus 1. And that would be, is that going to be 1? Well, like that. That'll be good enough. Okay, I is going to be, oh, okay, good. I was hoping for one of these. Integral from 0 to 1. Square root of y multiplied by y plus 1 dy. Okay, here I've got algebra and algebra. Okay, algebra plus algebra in this situation equals algebra. Okay, we don't need to do u dv on it. What I'm going to do is I'm going to distribute that, okay, using, okay, well, it's y to the 1/2. So this becomes the integral from 0 to 1 of y to the 1/2 times y is y to the 3/2, y to the 1.5. Plus, and then when I distribute that square root over here, I'll just have a square root, so that's y to the 1/2. Anti-differentiate, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power. Let y run from 0 to 1. Okay, when y is equal to 1, I'll have 2/5 plus 2/3. And when y is 0, I'll have 0 plus 0. Okay. And there we've got ourselves a value for that integral. And that's great. Let's see, the next one is going to be, oh, another good one. We got 2 more good ones coming up. So that, I skipped I. That was J, pardon me. I was too ready to move on from UDV. All right, so this is actually 1I. And integral from 1 to 2 of 4t to the 3rd log t dt. Okay, I late log before algebraic, so I'm going to let, let's see. Okay, so I let u equal log t, and then dv equal 4t to the 3 dt. Okay, making v equal to t to the 4 and du equal to 1 over t dt. Okay. Now using the integral of u dv equaling, I guess from 1 to 2, equaling u times v from 1 to 2 minus the integral from 1 to 2 of v du. Okay. Use that and have this equal to u times v, so t to the 4 log t, minus the integral from 1 to 2, I guess this is running from 1 to 2 as well, integral from 1 to 2 of v du. So v du is going to be t to the 3rd dt. Okay. So this is 16 log of 2 minus, when I plug in 1, I'll get 1 times the log of 1, which is 0, so I'm just going to leave that as it is, minus, okay, 1/4 t to the fourth, and I think that since this is an easy enough antiderivative, I'm going to try to do it all in one go. So 1/4 t to the fourth is 1/4 t to the fourth. Okay, and that's going to be a suitable answer for our purposes. Okay, I already did j, mistakenly thought it was I, so I'm going to move on to 1k. All right, this one, okay, we've got a product, but this is a composition of functions, so it's kind of making me think this is going to be u du. The derivative of x squared plus 2x is 2x plus 2, which is twice x plus 1, meaning that I'm going to need to do a u substitution. So I'm going to let u equal x squared plus 2x. So that du is 2x plus 2 dx. But I don't have 2x plus 2 dx. I have x plus 1 in it dx, so I'm going to basically factor out that 2 and solve for x plus 1 dx. So that's half of du equaling x plus 1 dx. Okay. Now, since this is a definite integral, I'm also going to need to convert the bounds. So when x equals 0, u equals x squared plus 2x is 0 plus 0 is 0. And then when I plug in 1, I'll get 1 plus 2 is 3. And yeah, so now I'm integrating as u runs from 0 to 3. This became half of du. And this is e to the u. Okay, so that's half of e to the u. As u runs from 0 to 3, that's e to the 3 minus e to the 0. Okay, and that's going to be our solution. L is integral from 1 to 2, x plus 2 times x minus 3 dx. Okay, it's again a case of algebra and algebra together. We're going to hit this with algebra. We're just going to distribute, right? So we're going to say this is the integral from 1 to 2 of x squared plus 2x minus 3x is minus x minus 6 dx. Okay, so when I plug in 2, I get 8/3, 4 divided by 2. And then when I plug in 1, I'll get 1/3 minus a half minus 6. And, well, there we have it. Got myself an integral. That's L. I've got one more. This is M. I don't even know where the remaining pages of this assignment are. Oh, here they are. Okay. So I'll be ready to go in a second. All right. So 1M. This is antiderivative of theta squared sine theta, d theta. And this is going to require integration by parts. And I'm going to say I-late algebra before trig. U equals theta squared, dv equals sine theta d theta. Okay. So du is 2 theta and v is equal to negative cosine theta. Okay. And one more time for you, I'm going to remind you that the integral of u dv is equal to u times v minus the integral of v du. So, yeah, this is becoming uv, so negative theta squared cosine theta, minus the integral of v du, so it becomes plus 2 theta cosine theta d theta. And this is going to require another integration by parts. So I'm going to let algebra before trig, u equals theta, dv equals cosine theta d theta. Okay. And then I'm ready to go, because this is this integral right here, I'm really ignoring all of this stuff. I'm just working over here. It'll be uv minus antiderivative of v du, so that's sine theta d theta. And we know an antiderivative for sine theta d theta, that's going to be negative cosine theta. And minus negative cosine theta will just end up being plus cosine theta. No d theta there, no need. Already integrated. But I will put in a plus c. Okay, but this is the thing that we are adding 2 of to this negative theta squared cosine theta. And there we go. That was all of the algebraic drill problems. Okay, so on to the next page. What's going on? Number 2. Okay, this one is work on the page. If f of x sine x dx's antiderivative is negative f of x cosine x plus 3x squared cosine x dx. Okay, so this is the integral of u dv equals u times v minus the integral of v du. Okay. We just talked about this problem in that class before the kids left, and it made so much sense then, and I'm kind of stuck. It's like, well, you know, is sine theta, or is sine x, is it going to be u or is it going to be dv? And I'm feeling like, how would I know? Because the derivative and, oh, no, okay, so if I took, it has to be that dv is sine x, because over here, to get, you know, negative cosine x, I didn't take the derivative, right? So dv equals sine x dx. That's what I know. Okay. Meaning u equals f of x. Okay. And so what I know is that, okay, v equals negative cosine x, which is the cause for that plus there. And then, okay, so I know that this is the integral of v du. Du is 3x squared. If du equals 3x squared dx, then u is equal to x to the third. U is f of x, so that's why I am choosing that answer choice. Okay. Then over here, x squared cosine x dx's antiderivative is f of x minus 2x. Okay, so that means that u is x squared, and dv equals cosine x dx. And got du equaling 2x dx, and v equaling, what's that going to be, sine x. Okay, well, this thing that would go right here at f of x, that's u times v, right? If we know the formula. So u times v is x squared sine x. Okay, that's that one. That was nice enough. All right, number 4. Let y equals f of x be the particular solution to that differential equation with f of 0 equals 4. Use separation of variables to write an equation for f of x. I bet one of the, them is going to be a little annoying, but it's all right. We can work with it. Okay, I'm going to say dy dx. This is number 4. Okay. And then I will separate my variables. Y to the negative 1/2 dy equals x cosine x dx. We're going to take the antiderivative of both of these. I'm going to add 1 to the power and divide by the new power. All right, x cosine x. Okay, let me make sure I haven't done this exact integral over the course of. Okay, I did it, I think, when I was working 1m, but okay, I didn't do it on its own, so I'm going to redo it. It's okay. So I'm going to go off to the side, and I'm going to say, all right, I algebra before trigonometry. So I'm going to let u equal x and dv equal cosine x dx, meaning du is dx and v equals sine x. Okay, and this integral is equal to u times v minus the integral of v du. Okay, so that would be end up being x sine x plus cosine x. So I'm going to just kind of copy that in. Okay, and then I'm going to start trying to solve at y. So I'm going to start by dividing by 2 and then squaring everything. So I'm going to call this x sine x plus cosine x plus c divided by 2, all taken to the 2 power. And now I've got f of 0 equals 4. So maybe I'll get another color. I'll come over here and try to find my value of c. So f of 0 equals 4. So 4 equals something divided by 2. So 0 sine of 0, so that's 0, plus cosine of 0 is 1, plus c, all divided by 2 squared. Okay. So that means to me that 1 plus c squared divided by 4 equals 4. So I'm going to multiply that 4 over there. That would be 16 equals 1 plus c squared. That looks to me like c could be 3 or negative 3. Just going to assume it's 3. That's very interesting. I don't remember that happening. We'll look and see what I said. Yeah, I just said it was 3 last year, but and I think I may have lied and said it could have been negative 3. Also, it wouldn't be negative 3. It would be, I think, negative 5 would be the other value of c, right? So I took negative 5 and I added 1 and then I squared it. I'd still get positive 16. Okay, but we'll just say that c is going to be 3. So y is going to equal, my solution would be x sine x plus cosine x plus 3 divided by 2 and squared. There's a variety of things we can do with integration by parts, right? We can apply it to separation of variables. We could apply it to area volume. You thought we were done with area volume. We're not done with area volume. Okay, we're going to set up and not evaluate an integral that represents the area of the shaded region. Okay, this is x log x is going to be the height, width dx. Integral from 1 to 4 of square root of x log x dx. And okay, we're going to use a calculator to find the perimeter of the shaded region. I am expressing doubt about the feasibility of that. Again, it's going vertical here, which, okay, it's 1 plus dy dx squared. That means that your integrand is going to infinity kind of at the edge of your integration, which makes it an improper integral, and we haven't done those yet. So I'm just going to say this is an improper integral. It's like 2 lessons from now, we'll learn about it. I don't know that this is going to be one that's able to be taken or not. The calculator will sometimes spit back a number for these, but I don't know that I trust it. So I'm going to have to do more investigation on that some other time. Find the volume of the solid generated by rotating the shaded region around the x-axis, and don't use a calculator. Okay. Well, try to fit it in the room that I've given myself. All right, so it's pi volume is equal to pi times the integral from 1 to 4 of r squared, where r is going to be that, right? That's my radius, top minus bottom. It's just square root of x log x. So if I take square root of x log x and I square it, I'm just going to get x log x. Okay, this feels a little familiar. I'm going to check and make sure I haven't already done this integral. I did 4t to the third log t from 1 to 2, which is close, but not exactly it. All right. I'm going to let u equal log x, because I late log before algebra, and dv equal x dx. Okay, so that u du is 1 over x dx. And v is 1/2 x squared. Okay, so this is becoming pi times uv 1/2 x squared log x, x running from 1 to 4, minus the integral from 1 to 4 of v du. Okay, v du, okay, when I divide the x squared by the x, I'll have 1 power of x, so I'll have 1/2 x dx. I'm going to do a little more work here before I jump back up to the top, and that would be 1/2 of 16 is 8 log 4. When I plug in 1, I'll have a half of the log of 1. The log of 1 is 0, so I'm just going to leave that as it is. And minus, I need an antiderivative for 1/2 x. That would be 1/4 x squared as x ran from 1 to 4. Okay, this would be 8 log 4 minus, and then I'm still going to use parentheses because I know I'm error prone. So 4 squared is 16 divided by 4 is 4. Minus, when I plug in 1, I would get 1/4. And that's going to be the volume. Okay, and that's far enough for our purposes. All right, find the area of the region enclosed by y equals 0, x equals 2, and y equals x e to the negative x. I don't even know what that graph looks like. Let me think about it. I think it's going to go up, then down. I mean, it's definitely positive, where x is positive. It starts at 0 at x equals 0. And it definitely has a limit of y equals 0. So I guess I can make a reasonable sketch of this. All right, so what I think is going to happen, not pulling out the calculator or anything, so I think it's going to go like that somehow. And then it's going to approach this horizontal asymptote. Now, where along here x equals 2 is, I have no idea, but this is y equals 0, y equals x e to the negative x, and also, maybe I'll just say 2 is right there. Okay. So I'm looking for the area of this region, the area of R. So what I'm going to do is I'm going to say that's the integral from 0 to 2 of x e to the negative x dx. I can just tell right now that I'm going to be needing more space, so I'll give myself a post-it note. So I'm going to need to use u dv because the derivative of negative x is not x. Okay, so u equals, this is not a u du scenario. I late algebra before exponential. And v is going to be negative e to the negative x to prepare for the chain rule. Okay, and then I'm going to say that this has become uv minus the integral of v du. Okay. And if I'm going to need more room, let's say this is negative 2e to the negative 2 minus 0, okay, plus the integral from 0 to 2 of e to the negative x dx would be negative e to the negative x, so negative 1 over e to the 2 minus negative 1 over e to the 0. Okay. Let me make sure about this. I'm not trusting that. All right. Oh, and if you simplify this, you can see, okay, I was a little concerned. I was like, man, this kind of looks like maybe a negative number. And I know it's got to be positive, right? Because x e to the negative x is a positive function where x is bigger than 0. Okay, let's combine these. I'll have a positive 1 here, 3 over e to the 2. But we know e to the 2 is much bigger than 3. So this is going to be a fraction that's less than 1. And if I subtract it away from 1, I'll still be positive. It'll be all right. Okay. Okay, done with this one. I could even write on it. Last page. If g of 2 equals 1 and g prime is x cosine pi x, find the value of g of 1. Something we haven't talked about for a while. F of b equals f of a plus the integral from a to b of f prime of x dx. That old formula. You like that formula. Let's see. What paper, I think. All right. So we know that g of 1 equals g of 2 plus the integral from 2 back to 1 of g prime of x dx. Okay, and I can do this. This is going to require an integration by parts. I late algebra before trig. Derivative, antiderivative, okay. And so g of 2 is equal to 1. So this is equaling 1 plus uv as x runs from 2 back to 1, minus the integral from 2 to 1 of v du. So I'm going to pull out the 1 over pi sine of pi x dx. Okay, and what's going to happen here? All right. 1 plus, now, sine of pi and sine of 2 pi, both 0. Okay, that's going to be very helpful. Okay, that's just going to be 0 minus 0. That's going to make my life way easier. All right, antiderivative for sine of pi x is going to be negative cosine of pi x divided by pi. So I'm going to have a plus, right, because the negative cosine, 1 over pi squared times cosine of pi x as x runs from 2 back to 1. Okay, when I plug in 1, this is something I need to be careful about. 1 over pi squared multiplied by cosine of pi is negative 1 minus cosine of 2 pi is like cosine of 0, and that's positive 1. So again, I was a little worried that this was going to be a negative number, but pi squared is much bigger than 2, so it's going to be all right. And that'll be fine. All right. let f of x equal x to the 7 log of x. Find the average value of f on the interval 1 to 10. Oh, okay, that'll be a good one. Might still look this on the pad. Yeah, it's going to take too much room. All right, so the average value of f on the interval 1 to 10 is equal to 1 over 10 minus 1 times the integral from 1 to 10 of f of x dx. Okay, so I'm going to take this and divide it by 9. So take the integral and then divide by 9. So I've got u equals, I late log before algebra, and dv equals x to the 7 dx. Okay, so I take the derivative, take the antiderivative, and then I'm going to go over here and say this is equal to 1/9 of, I know I've said it a bunch of times on this video, but I'm going to say it once more, that the integral of u dv, I don't have anywhere to put it, but I'm squeezing it right here, equals u times v minus the integral of v du. Okay, 1/9 of uv minus the integral from 1 to 10 of v du. That's 1/8 x to the 7th dx. Right, and now, well, I know when I plug in 1 into log, that'll give me a 0, so that's going to make it not so long. So I've got 1/9, and then what I've got here is 1/8 of 10 to the 8th times the log of 10. All right. So I'm going to call that 10 to the 8 divided by 8 multiplied by log of 10. Okay, that's this part. Because when I plug in 1 into log x, I get 0. Minus the integral from 1 to 10 of this. So add 1 to the power, divide by the new power. That's minus 1 over 64 x to the 8. And then, well, that'll be 10 to the 8 minus 1 to the 8. And that's going to be the average value. Okay, that was a little intense, but you know, it's something that we can do. Starting to realize that there's no table question on here. That's not good, but you know, if you're watching right now, I really encourage you to make sure you're able to do that table question from the notes packet. I think there were 2 of them on there. Anyway. Object starts at the origin and moves along the x-axis with velocity given by v of t for t between 0 and 2. Write an equation for the acceleration and position of the object at time t. All right, we've only got 2 more. And, well, how do you know? Another really long video. So, these homeworks have gotten long, it seems like. Acceleration. Okay, I'm going to take the derivative of the velocity function, and I'm just going to factor out the 1/10, and then I'm going to use the product rule. Take the derivative of t first, leave e to the 3t the same. Then I'm going to leave the t the same and take the derivative of e to the 3t. Okay, right, t stayed the same. The derivative of e to the 3t with respect to t is going to be e to the 3t times 3, so that's where the 3 came from in there. And let's see. Oh, that's the derivative for the acceleration. We're going to need to find the position. Okay, x of t is going to be the antiderivative of t e to the 3t divided by 10. So I'm going to actually write it like that, dt. And then starts at the origin. We'll see what we have for c. It might not be c equals 0, now that I think about it, because of that e to the 3t. We'll see what's going to happen here. This requires u dv. I'm going to let u equal t and dv equal e to the 3t dt. Okay. And I'm going to say that this is equal to 1/10 of uv minus the integral of v du. All right. So this is going to be t over 30 e to the 3t. This antiderivative is going to be minus 1/9 e to the 3t plus c. And yeah, so that's x of t. X of 0 equals 0. So if I plug in 0 for time, this is going to be 0. This thing would be 1. So I'd have negative 1/9 plus c needs to equal 0. I've got c equaling 1/9. So x of t equals t over 30 e to the 3t minus 1/9 e to the 3t plus 1/9. And there we have it. Right. This next problem, this is not part of AP Calculus. You do not need to worry yourself over being able to do that. I think it has UDV and then UDU. I'm going to do arctangent, and we'll see if I still feel like doing arcsine after that. I don't think it's actually that bad, but I am going to give myself more room. Okay, so derivative for inverse tangent. And it says use UDV and then UDU. Yeah, definitely. I know how this goes. I've done this before. It's just been a little while. All right. I don't even remember what number that was. The last one. I don't know. Antiderivative of arctangent x dx. Okay, I'm going to do a UDV. I'm going to let u, if I'm trying to find an antiderivative in the first place, I better not let dv equal inverse tangent, because then it's like, well, what is the antiderivative? U equals arctangent x and dv equals dx. Okay, we know that the derivative of arctangent x is 1 over 1 plus x squared, and that'll give me v equals x. Okay. By this point, you know that the integral of u dv is equal to u times v minus the integral of v du. Well, I forgot my dx over here, but it's all right. X over 1 plus x squared dx. Okay, this sets up really nicely for u du, because this is a u prime over u scenario, so I'm going to let u equal 1 plus x squared. Spread. Let u equal 1 plus x squared, so that du is 2x dx. I only have x dx, so I'm going to end up with half of du. Then I'm gonna, what am I gonna do? Oh yeah, x arctangent x minus, all right, this is 1 over u times half of du. So half of 1 over u du. So this is x arctangent x minus half log absolute value u was 1 plus x squared dx plus c. Okay. Tell I've been at this a while. It's a long day and week at school this week. Okay, that's an antiderivative for arctangent. I'm going to do it for arcsine as well. You know, if I'm going to put it on the homework, I better be able to do it. Or if I'm going to make a homework that long, I better be able to sit down and do it. So, although I don't recommend anyone do these homeworks in one sitting, I don't think that's the thing to do at all. But okay. antiderivative of arc sine x dx. Okay. I'm going to let u equal arc sine and dv equal dx. Okay. And all that, I know about the formula for u dv, so it's going to be equal to u times v minus antiderivative of v du. Nearly panicked. I was like, oh, that minus x squared. Did I remember to use the minus in the last one? I remember that. Okay, the derivative of arctangent is 1 plus x squared. And, okay, don't have to worry about it. So I'm going to go in now, and I'm going to say this requires u substitution. So, wait, whoa, that's going to be negative 2x. Negative 2x dx. And if I just have a positive x dx, I'm going to have negative half du. All right, and that's going to leave me with an x arc sine x minus, well, I guess it's going to be plus, right, because of the minus negative half of the integral. This was, pardon me, I can tell I'm getting tired, and this is not even a v du. Okay. When I change this into a u integral, x dx became du, well, negative half du, and this is the square root of u. So I'm going to say that's equal to x arc sine x. All right. When I add 1 to the new power and then divide by the new power, I'm going to have exactly this u to 1/2, right? Because I'd have u to the 1/2. I could look at it as multiplying by 2, which would kill that off, or dividing by 1/2, which would kill that off, just the same. And I'm going to have plus the square root of u, so plus the square root of 1 minus x squared plus c. And that's all I got for you for this video. Thanks for watching.